All right, so this is the key for the warm up. All right, so number one, you should have had x is 72 degrees, y is 61 degrees. 2, y is 5, x is 6. For 3, you should have had x equals 5 and y equals 7. And for this guy right here, KT would have ended up being 108. I'm going to give you a few minutes in case you missed something, check the work, and then let me know what questions you have.
He looks. I think I would battle a little bit more than not. I would be like, what's the problem? What's the big one? Well, I mean,
All right, show of hands who is still looking at this. So remember, I would use this to your advantage for your quiz this weekend. All right. Anybody still looking at it? Going once, going twice? All right, take out your companions. Let's get going and take out those calculators as well. Take out your foldables.
I had nothing but ankle socks. I had wear ankle socks all No, not. It was terrible. I thought you were most of the time in Florida I just do. That might be right. I hate it. Like, ankle socks are just like behind it. Yeah. If the Minecraft spider breaks its way back to my house again.
What's outrageous? All right. All right, open it up to page. I don't remember. Okay, open it up to page 139. Okay, 139. Okay, so take out your foldables also. We're going to look at the properties of a trapezoid. All right? Now, the properties of a trapezoid state one pair of opposite sides are parallel. Adjacent angles are supplementary. The median is parallel to the bases and divides the non-parallel sides into congruent parts. So there's 3. So that is just the basic properties of a trapezoid. Okay? Now, if you guys look underneath, because this is what we're going to be dealing with a little bit more today, is a trapezoid is isosceles if, open that up, you have the lower base angles and upper base angles are congruent. Diagonals are congruent. Lower base angles are supplementary to the upper base angle. Now, because it's, yes, Carol? We're on 139. Now, all the properties of an isosceles trapezoid still contain the properties of just a trapezoid. So not only for isosceles trapezoids do you have all these 3, you also have these 3 on top associated with it as well. Does that make sense? That's how these if parts go in your foldable. It says a trapezoid is isosceles if. So that means it's taking all the properties of a trapezoid along with adding on a few extra. Okay. Evan, everything okay?
No.
Oh, need some glue. Just grab some glue. It's fine. I would use the liquid glue this time. It'll stick a little better. Okay? Does that make sense? So you have everything available to you. Now let's take a look at number 3. It says explore parts of an isosceles trapezoid. Keough is designing a trapezoid-shaped roof. In order for the roof to be symmetric, the overlapping triangles, triangle A or DAB and triangle ADC must be congruent. Will the roof be symmetric? So again, we're still applying these properties that we've learned before, okay, about triangle congruency. So we're trying to show that these two are congruent. And again, it doesn't take long to do that. If this is isosceles, you know that these two legs are going to be congruent along with this angle, and this angle is also going to be congruent. Okay. And we're talking ABE. We know that this right here is going to be a right angle, and this is going to be congruent with that because it forms a rectangle in the middle. So in this case, you have a hypotenuse and a leg, and therefore these two triangles are congruent by HL. Okay. Again, it doesn't take long to view this and see how these triangles are congruent. We're not doing the formal 2-column proof, but the rules are still applying from topic 4. All right, now that you have those, it says show that DAB is congruent to ADC. So in this case, if you're looking at this, you're going to be using CPCTC for angle DAB and ADC. So let's see, D to A to B. So they're talking about this guy and this guy. So those two, again, are congruent, but they're also, it's an isosceles trapezoid, so we already knew those were congruent. By the reflexive property, and then by the reflexive property, this line is congruent to itself, okay? So in that case, because you have the two angles, you have a side and you have another side, these two are congruent by side, angle, side, okay? So let's take a look at our triad example. It says, given isosceles trapezoid PQRS, what are the measures of P, the measure of angle P, the measure of angle Q, and the measure of angle S? So all we would need to do here is know what we, is this thing recording? It's supposed to be. Where's the tool? Oh, well. Hold on. Ah, there we go. Let me hit play again. Sorry. Here we go. All right, so given isosceles trapezoid PQRS, what are the measure of angle P, measure of angle Q, and the measure of angle S? All right, so things we need to know. First off, since this is an isosceles trapezoid, providing this will let me write, certain rules apply. First off, this is congruent with that. This angle is congruent with this angle. This angle is also congruent with this angle. So it makes it pretty easy that since we know angle Q is congruent to angle R, the measure of angle Q is going to equal 135. So that was kind of nice. Now, again, according to our foldable, it also says that, where was it? Just under the properties of a trapezoid, it said that we have adjacent angles are supplementary. So which means this is going to be supplementary to this if we want to find the measure of angle S. So for the measure of angle S, we're going to have 180 minus 135, which gives us a total of 45 degrees. And again, since angle S is congruent to angle P, we know that the measure of angle P will also be 45 degrees, provided I can actually write a 5 on here. So our answers, measure of angle Q, 135, the measure of angle S is 45, and the measure of angle P is 45 degrees. Yes? Yes. I think that's how they put it. Or did they call it 6-1? I can't remember. Sorry. Let me see what I can. I think they called it. How did they do it? Hold on. Let me go back here a smidge. Come on now. Sorry, this thing is like lagging bad. Okay, here we go. Yeah, it's. I wouldn't even call it isosceles trapezoid theorem. What I would do is I would state like property of an isosceles trapezoid because it's one of the properties. So rather than stating a lot of times though, I'm not going to lie to you, because there's so many properties within one, you're going to have to state like the physical property. You would have to state that, you know, if an isosceles trapezoid, then base angles are congruent or legs are congruent. Or does that make sense? Like you're going to have to physically apply the parts. That would be the reasoning, yeah. A lot of times it's done as an if then. Okay. There's no shortcuts in this one. That's why you guys have to remember them all. Okay, good question though. Any other questions before I move on to the second example? All right, so letter B, they're saying ST is parallel to RU, okay? And you have these congruent legs. So the question is, do we have an isosceles trapezoid here? Yes or no? We do. So diagonals, all those properties apply. Diagonals are congruent, you know, base angles are congruent, and the other top angles are congruent, but they're also supplementary because it's a trapezoid. So in this case, they want you to find the measure of TUR. So T to U to R. Well, if this is 47, we know that these two should be supplementary, right? Adjacent angles are supplementary in a trapezoid. So to find the measure of angle R, we're going to first find the measure of angle R. Sorry, not R. Boy, oh boy. SRU by taking 180 minus 47. Oh my gosh, come on now here. Come on, Smith. Here we go. Okay, and that's because this and this form a linear pair. So the measure of SRU ends up being 133. So if this is 133, and we know without a doubt that this is going to be congruent with this, then this angle must also be 133 degrees. Questions on that? Anybody still writing? I am going to erase. All right. Okay, we're going to skip this example. Just want to go to we are going to do B though. Actually, no, we're just going to go straight to example 4. It'll be easier. Okay, so in this case, given isosceles trapezoid N or MNOP, where the given expression represents the measures of the diagonals, what is the value of A? Okay, so in this case, remember, if we have an isosceles trapezoid here, we know this is congruent with this. We know that angle is congruent with that angle. We know this angle is congruent with this angle, but we also know that the diagonals are congruent. Because the diagonals are congruent, and they're saying that they said this expression represents the diagonals, we just set them equal to each other and solve. Now, if they give you little parts, and they give you, let's say, again, this is an if situation. Let's say they give you this, and then they give you this as separate parts. You would know that this is A plus 13, and this small part right here would be 2A minus 1, okay? That's not like they're saying they're parts. But the diagonals are congruent, so those little parts have to be congruent as well. Does that make sense? So just something to keep in mind. That's all. Any questions on this one? I mean, it's pretty easy, right? Okay, do take a look at the habits of mind, though. That's all the way at the bottom. So it says, what is the minimum amount of information you need to find the measures of all 4 interior angles in an isosceles triangle? So what's the minimum amount of information to find all 4 angles? Who can tell me? Yeah, you need at least one angle. If you don't have one angle, you can't solve for the others, okay? So sometimes, like, and this is just kind of reiterating back to the topic for tests. Some of you kept saying, oh, I'm using, you're adding segments together, but then said they were angles. So be careful with that kind of stuff, okay? Just kind of get it a little more straight. Questions on this? All right, let's take a look at example 5. All right, so if you look at your foldable, it is in here too. It says trapezoid mid-segment theorem. It's also known as a median, okay? So look at the median of a trapezoid. But the thing you're going to want to add here is, because this is not in there, you're going to want to add this if-then under the median and label it as trapezoid mid-segment theorem. Okay? You're going to want to add that to your foldable probably. So one thing I couldn't fit in. So it's either a median or it's a mid-segment. Either way, it gives the same properties, okay? What happens is, in a trapezoid, the segment containing the midpoints of two legs is parallel to the bases, and its length is half the sum of the lengths of the bases. So I gave you the algebra. You guys need to add in the if-then, okay? So if you have xy as that mid-segment, also known as a median, okay? It could kind of show up either way on a test. I know on the quiz it'll show up as mid-segment, okay? Then it is x and y are acting as midpoints of CD and AB. So these two parts end up being congruent, these two parts end up being congruent, but it's still under trapezoid, so we still have the parallel lines. They're not saying, and this is important, they are not saying that AB is congruent to CD. They're not saying that, okay? So don't assume that. But what happens is this also, in order to find the length of XY, you just take 1/2 the sum of the top and the bottom, okay? Is anybody still writing down the if-then? You don't need the picture, you just kind of need if this is happening, then this. All right, let's apply an example. All right, so it says, Paxton designs and makes trapezoidal handbags. She stitches decorative trim along the top, middle, and bottom on both sides of the handbags. How much trim does she need for 3 handbags? Okay, so in this case, if you look, here's our trapezoid. We have 2 inches, we have 2 inches here, 2 inches here, and 2 inches here. This is one of the things, if you look at this one is isosceles, because you have physical evidence that not only are these parts congruent, but they add up to be the same thing. But never assume it. They have to give you something, okay? So if we're going to find this mid-segment right here, we're going to just apply the formula of 1/2, 6 plus 9, giving us 7.5. So find the amount of trim that Paxton needs. First, find the amount of trim for one side. In this case, 6 plus 9 plus 7.5 is 22.5. Then multiply it by 2, so she needs a total of 135 inches, okay? Let's take a look at our next example. So this was just a very basic mid-segment algebra formula, algebra example. Well, this is just a context example. So they're asking, you need a front of a handbag and the back of a handbag, right? So that's why they multiplied by 2. Okay, let's take a look at the next one. So it says, given trapezoid JKLM. All right, JKLM. What is KL? So in this case, I'm labeling this as X because I don't know what it is. The other thing here I'm looking at is I have 4/5 XY. So they gave us XY as 25. So I'm going to take 4/5 of 25. This leaves me with 20. So now if I talk about the mid-segment theorem, you would have 1/2 times KL plus JM. So I'm going to have, and that's going to equal XY. So in this case, 1/2 KL is X, because I don't know what that is, plus JM, which is 20, equals 25. What do I do from here? Yep. Multiply by 1/2, you said? Now multiply it by half. Close. You can divide by 1/2, or you can multiply both sides by 2, right? So this will be X plus 20 equals 50. Subtract 20 from each side. So I have X equals 30. So if X is equal to 30, that means KL is 30. And we're going to put meters. And there we go. Questions on this? Anything? Going once, going twice. Okay. Before you go, I'm going to give you guys this other half sheet for just a few extra examples for trapezoids. I want you guys to complete these. Okay. If you don't complete them in class, that's fine. But we're going to go over them tomorrow. But don't forget your homework is on Realize. Okay? Yeah. It's 4 additional problems. They're pretty good. And like I said, these will mimic the tests and the quizzes. So.
Just a little.
Evan, you all right?
I don't know. Maybe asking her. I took my pencil for like 4 seconds. So I think
Okay.
what else?
Those of you watching at home, have a wonderful day.